Hello guys, back with another video, this time on gib strip. So in my previous video I shown you how I grind the both side of the dovetail, and so because of that grinding the other thing happens to it. Basically I had literally about little bit more gap, so I needed to get a bigger gib strip for my cross slide. The plan is to make a gib strip from a mild steel bar, and ideally for again making a gib strip it requires a milling machine to get something precise. But today I'm gonna try a new method, and I'm gonna use my Mitre saw to cut that gib strip. So I need to hold the mild steel into the clamp or vise, whatever, and basically make a cut at the 60 degrees angle. But the problem is this Mitre saw, the maximum angle that cuts is literally 45 degrees. So in order to cut my mild steel I need to print a file, or basically a base, so I can tilt mild steel in 15 degrees, so plus 45 degrees on this, plus 45 degrees of cut, it's gonna end up be 60 degrees. So I'm gonna repeat the cut for the both side, and hopefully we're gonna have a nice gibs. Okay, this is the part that I designed and built on the PC. So I print it, and that's how it goes. So basically I can place my mild steel into it and clamp it. So what it does, it gives like a 15 degrees angle to mild steel. But before cutting my mild steel, what I want to do, just first cut it in a length, and also try to do the sample on the smaller part, see how it goes, and then try it with the bigger part. Right, now I'm gonna try do the same thing to the big one, and do it from the both side. But I need to cool it down somehow. Right, now I've placed the big part in, and also bring some water and see how it goes. Right, now the one part is done. So I mean one side is done, and there is another piece, triangle, that goes underneath just to keep the gib in a right angle like this, and let's give it a go. And so let me show you. After grinding my dovetail, the cross slide dovetail, as you can see, there is a lot of space for the original Gibbs strips, and I don't like it. The reason I built mine, because let me place it back. And that's the way it should look. So I already tied up the Gibbs screw, and take this off to basically to get some mark. So where these points are, I'm gonna use my Dremel tools to just give a little bit more dent in it, so simply to lock the Gibbs strip in place, it doesn't move while the cross slide crossing the bed. Perfect. It's very rigid, and I'm very happy with this. I feel no whatsoever movement in it, and I didn't put any pressure on it. So what I'm trying to show you, what I can do, just with no pressure, I can twist. Very good. The Gibbs strip is turned up good, and I'm not claiming that the part is completely precise. One end it was slightly smaller than the other side, because first of all my setup wasn't rigid enough, and the other thing, this 3D printed part start to melt it, so the part came loose. So what I'm trying to say, if my setup was better, I mean it was more rigid, I could make a very precise Gibbs strip. And anyway, it was just a proof of concept that how a Gibbs strip can be made on the Mitre saw. And that's it. Thanks for watching. Please give me a like and subscribe if you are new to the channel. See you next time.